Chapter 10 Circle. First we will see the definition of a circle. A circle is a collection of all the points. These points I am talking about on this circumference is a collection of all the points in a plane which are at a constant distance from a fixed point. This is the fixed point and distance of all these points will be same from here. Then a circle has different parts, and you can see this circle, this line itself is known as circumference. That boundary I am talking about, that closed boundary is known as circumference of the circle, and the line segment whose endpoints are on the circumference of the circle, this line segment is known as chord. Even this line segment also known as chord, since it passes through the center, its special name is given to it as a diameter. So diameter can also be considered a special case of a chord which passes through the center of the circle. Then this length OC, OR and OP is known as the radius of the circle. This OR, OC and OP is known as the radius of the circle. Then this diameter divide the circle in two parts. This is known as this side, this side is known as a semicircle. Let's see some more. In this chapter we will talk more about tangent. What is a tangent? When a line touches the circle at only one point is known as tangent. The word tangent itself came from the Latin word tangi, T-A-N-G-E-R-E, tangere, which means touch. The word tangent came from the Latin word tangere, T-A-N-G-E-R-E, tangere, which means touch. And then if this same line, if intersect or cut the circle at 2 points, then this line is known as secant. That means a secant is a line which touch the circle at 2 points or cut the circle at 2 points. And a tangent is a special case of a secant where these endpoints A and B of the line segment AB will be coincide. That means both this A and B will come and meet at one point. If I'll move this one down, then you can see the chord will be smaller and smaller. Ultimately become A and B will coincide with the point P, and that will become a tangent. Let's see theorem 10.1. Theorem 10.1. The tangent at any point of a circle, I mean this tangent at the point A, is perpendicular to the radius. That means OA must be perpendicular to XY. Through the point of contact, this point which touches the circle and common to both circle and tangent is known as point of contact. So I have taken, let XY be a tangent to a circle at a point A, and O is the center of the circle. I have joined OA, and then we need to prove OA is perpendicular to XY. This. Let's see the construction part. We take a point here or anywhere except the point A. We can take another point on this line XY anywhere except the point A, and I name that point as B. And if we join B and O, it will intersect the circle at a point, say R. So I have taken the construction, take a point B on XY other than A, and join OB to intersect the circle at R. So intersect the circle at R. Now if you look OB, if I am going to take the proof, OB contain two parts, OR plus RB. This is what I start with, that OB equals to OR plus RB. See, OB equals to OR plus RB, and this is what I wrote it here. OB equals to OR plus RB. And OR I replace by OA, and remaining these two parts is same. Why? Because OR and OA both are radius of the circle. Look, OR and OA both are radius of the circle, so I replace OA by OR by OA. I replace OR by OA. That means this is equals to OA plus RB. The sum of two part is equals to this the whole. That means each of this part is always smaller than the whole. If you look an example, if I'll give you, if you look an example, suppose 5 is equals to 4 plus 1, then 5 will be always bigger than 4, as well as 5 is always bigger than 1, because both of them, they are the part of 5, so the part of a whole is always smaller than the whole. That was the Euclid's postulate we have learned in class 9. This is what I am using here. So this OA is smaller than OB. Even RB is also smaller. Since we need OA as a part to prove it, so I have taken OA. I have taken OA. So OA is smaller than OB, or OB is greater than OA. And this is true, which is true for every point on the line XY except the point A. That means this statement, that is OA is always smaller than OB. In other words, OB is always bigger than OA, and this will be always bigger whatever be the position of B. You may take here, you may take here, you may take here. The length, if you look, is always bigger, except the point A. When it comes, this B will come here, they will become same. If you take it here also, then also this will bigger, this will bigger, this will bigger. Anywhere you can take this. I wrote it here, which is true for every point on the line XY except point A. That is, OA is the shortest of all the distances. OA is the shortest of all the distances of the point O to the points of XY. That means if you take any point here, that means OA is always the smallest, and the remaining point, the distance of all the point from O will be always bigger than OA. And therefore the shortest distance is always the perpendicular distance. If you look page number 332 in old book, page number 332 in your old book, then you can see there is theorem A1.2 or new book. If you look theorem A1.2, just before the exercise A1.6 is given there. Out of all the line segment, I'll show you. If you look, is given here, of all the line segment drawn from a point to the points of line not passing through the point, the smallest is the perpendicular to the line. This I was talking about. If you look this, according to this theorem, this is given that OA, we can write that OA is perpendicular to XY, or in symbol, and therefore we can write OA is perpendicular to XY, and that is the proof of theorem number 1. Thank you.